In this video, I'm going to explain why I needed a power failure alarm to be tied in to an existing high water alarm on this sewage ejection pump, and why I needed to create that myself. I'll take you through how I initially built the alarm and how I did some modifications later to achieve similar results a different way. So feel free to scan through the video. I would suggest trying to at least watch the end to realize some of the modifications I made to determine if you want to make those up front in your project. So while you may not watch the whole video, definitely scan through and get a sense as to where I started and where I wound up. And I hope that this is helpful for you. And I apologize for the portrait mode. I'll make sure I try to do this in landscape when I do something next time. Thank you. In my finished basement, I have this sewage ejection pump, like many of you probably do. It has a alarm float, high-level float in it, that feeds this Liberty alarm pump. Pretty standard pump, dry contact in. When the float rises, it shorts the contact, sets off the alarm. This alarm in particular has a battery backup, a 9-volt battery backup. It has a power supply from the outlet, and it also has auxiliary contacts out, which I'm using to trigger a yodeling sensor, which will shut off the whole house water system by way of a water valve robot. So not only do I get the audible alarm, but it will also trigger the water shut off. I was looking for a way to also be alerted to a power failure condition should this circuit trip. And what I found was that most alarms that had power failure monitors were immediate. So as soon as the power failed, you would be alerted. I don't want to know that because we get blips, and I also have a whole house generator. So I only wanted to know when the power on this circuit had tripped for greater than, say, 45 seconds. So I went looking for a solution and decided to put one together myself based on a delay timer circuit that I will link to on Amazon. So for my power failure alarm, I'm going to use this delay timer circuit that I got on Amazon. It came in a 2-pack. I'll put a link to it. I've also used this waterproof project box with a mounting grid. I don't need the waterproof nature of it, but I liked that it came with a clear cover. Gone ahead and mounted everything. I've used a standard 4-conductor solid telephone cable that's going to both send my trigger voltage from the Liberty alarm as well as the contacts to trigger the Liberty alarm. We'll get into that in a minute. This black cord is a 12-volt DC power that I just had a power supply hanging around. This board will take anywhere from 6 to 30 volts, so I'm using this 12-volt power supply. You could also use a micro USB, if you so choose, to power it. So at this point, we've got the circuit mounted in the box. We've got everything kind of dry wired up. I've got some strain reliefs put in place. I've got a bracket to mount the box. I couldn't find a particular box available quick enough that I wanted that had mounting tabs, so I've just put a bracket on it. So again, at this point, we are kind of dry fit and ready to move on to the next step. We've got our unit hooked up. We've got it plugged in. I've got constant power coming in on this 12-volt power supply that I mentioned. Remember, I've got my green and yellow, my normally closed relay contacts. My black and red are my trigger voltage. I've got my relay contacts connected to this ohmmeter. I've got the trigger contacts connected to this 12-volt power supply. And right now it's actually counting down because it's in its default program. And what we're going to do now is we're going to put it into the program that we need for what I'm trying to do. You can read the manual for what exactly you're trying to do. I'm going to press and hold the set button. It's going to bring up this P1.1. I'm going to use the down key to get to P4, which is what I want. I'm going to press set again. This is my timer, my OP timer, currently set for 1, 2, and you can see that the decimal is all the way to the right, so that's 12 seconds. I'm going to put it down to 5 seconds for this purpose. If we hit the combination of buttons, we can get the decimal point to move. The stop button, I believe, moves the decimal point. Yes, it does. So that's 5 minutes, and so forth and so forth. So we're going to go back to 5 seconds. And then I'm going to press and hold the set button, or P4. I'm going to press the stop button. And now we're back to this mode. So right now, if we turn our ohm meter on, we'll see we are shorted. So we are in a closed and alarm position at this point. We have trigger voltage applied. This is because the unit is off. So we're going to press the start button to put it on. We're going to reapply our trigger voltage. We're going to disconnect it and reapply it. And you heard the relay click, and there's a red light that comes on, and the display reads 0. Our ohm meter now is in an open position. The relay has opened up, or activated, and I'm using the normally closed contact, so therefore it is open. So this is a non-alarm condition as far as the water alarm is concerned. At this point, if I remove my trigger voltage, so this will be voltage that I'll be getting from the Liberty alarm panel that indicates when that circuit has lost power, and we'll go over that later. But for now, we'll remove our trigger voltage by disconnecting this lead, and you'll see the display counts down 3, 2, 1, relay clicks. We are now in a closed position or an alarm position from my standpoint. Let's reapply the trigger voltage by connecting the power, the trigger voltage, and I can unhook that and unhook that many times. I know it's hard to see on this display. Let me angle it a bit. But I can, during the countdown time, I can continue to apply and unapply that, and it will keep resetting the timer, which is good. So if we get power fluctuations, every time that power comes back, it resets the timer when I disconnect it. Now, we go to this state here. So now we're in alarm condition again. Power comes back. We're in a non-alarm position. So this is the basic principle. We're back in the pump closet. I've got the newly created timer relay in the box mounted on the wall. You remember I had this Yo-Link sensor, which is wired into the pump alarm to disconnect my whole house water. I've unhooked that for now so that I don't trigger the whole house water shut off. So let's review what we have. We have a sewage ejection pump that connects into a GFI protected outlet through a normal high voltage float switch. Water level rises, float switch kicks in, pump turns on, water level goes down. If something fails, if the circuit trips, pump breaks, whatever it may be, water level gets high enough to where it will trigger the alarm float. The alarm float is just a simple wire right here. This is a simple contact that goes into this Liberty pump alarm. Now, a lot of companies make these types of alarms. There's nothing particularly unique about this Liberty version over probably another. The way that this alarm is designed is it has a common and then 2 alarm inputs. It doesn't really matter. These are just shorted into, they're on the same trace inside the alarm. They're just essentially shorted to each other, so I could just as easily put 2 wires on this one and rather than separate them. Doesn't change anything. So what happens is the alarm float triggers, essentially shorts these two contacts. This alarm beeps, makes a very loud noise. But this alarm, one of the nice features this particular model has, is it has not only the backup, the battery backup, but it has these connectors on the side. These top two are an auxiliary power source. So I have a plus and a minus. These outlets here are directly tied to the output of this transformer. This is 11 volts that supplies this unit. So on these contacts, I get 11 volts whenever this outlet is working properly. If I disconnect this outlet, or it trips, or this transformer breaks, or whatever it may be, I'm going to lose 11 volts on this line. But the battery is still hooked up, so the alarm itself will function. I just don't have 11 volts, which works perfect for my case because I can use this to detect when power has failed on this circuit. If you didn't have this, you could do something. You could just grab another power supply you've got hanging around, plug it into the same outlet as your pump that you're concerned about, or whatever it is, and just feed that directly to the trigger line on the timer. I mean, I'm just saving a step here because I've got the output. This also has a dry contact output. So when these get shorted by the high water condition, this also gets shorted here as an output. And I use this to trigger the Yo-Link. So I trigger a closed connection here, which this connects to my YoSmart Yo-Link system, kind of beyond the scope of this, but it triggers a high water alarm condition, which triggers my whole house water shut off. So, high water alarm here, triggers this, Power, but now we're going to be able to monitor for power. So if I lose power in this circuit, and I'm going to simulate that by just unplugging the alarm in a second, you'll see that the 5-second countdown timer that we set before will start. It takes actually a second for it to drain and trigger, but there it is, 5, 4, 3, 2, 1. It's going to be very loud. I'm going to cover the... Okay. So you see, and that alarm will continue until power is restored. I'm going to silence it right now. But you see that we're still... we have an alarm with a buzzer disabled. Actually, the alarm buzzer is disabled. But you see I plugged power back in here. Green light came on. This guy's happy again. If I turn that to normal, I no longer have an alarm condition. We'll repeat that again. I'm going to unplug power to the alarm, or I can actually just, I could trip the circuit breaker, but I'll unplug power to the alarm. Count down. 5, 4, 3, 2, 1. Silence it. You notice we don't have an LED there. It's not receiving power from the trigger, but I'm going to plug it back in. And the alarm comes back on. We have a trigger again. So life is good. And oh yeah, by the way, I remember my constant source. I have plugged into a UPS backup over here. So that's the story. I hope this helps you. Thank you. After I went ahead and put this in, I started thinking about some modifications. So first, real easy, I drilled some holes for ventilation. Maybe not necessary, but I thought that, you know, this circuitry could generate some heat, and it was basically in a completely sealed case. So drilled a few holes, easy enough. Next thing I thought about was, well, let's talk about the relay contacts. We talked about originally how the way that it was wired before was on the normally closed side, and that was essentially a fail-safe. So if the circuit ever lost power, then the contacts would close and there would be an alarm condition. So you can actually argue that a couple different ways. One is there are instances where relays are essentially get welded into a closed position. Usually that's in high current scenarios, not something I would expect to happen here, but it's one possibility. The other situation is that This device was running in an always energized state, the way that I had it before. The relay was always energized, therefore keeping the normally closed contact open. So I was using about 96 milliamps of power to keep that energized all the time. Not a huge deal, but I thought about, well, what's the lifespan of a relay that's energized all the time? If that relay were to fail, then I could essentially, get a false alarm and then have to replace my relay. And so I thought about flipping it around and saying, well, what if I use the normally open side and essentially reverse the logic so that on an alarm I'm going to close on that side by activating the relay instead of inactivating the relay. So that's what I did. And actually this timer circuit has a really cool feature where we can keep all the programming we had. All we do to do that is we go from our contacts from the normally closed side to the normally open side, and we press and hold the down key. It goes from what they call F1 to F2 mode, so essentially reverses the logic. So now you see that this red light is not on. That means the relay is not energized. I'm in a normally open condition and my ohm meter is reading open. So life is good. I have no alarm condition. If I remove power from the device, you'll see my countdown timer starts. The relay will energize and I have an alarm position at this point. We connect power again. The relay de-energizes and I have an open position. So that brings me down to the third modification. And that was, what if I want to remove the source of constant power, that extra power supply? You may remember I've got 11 volts coming from the Liberty alarm system. What I decided to do was that 11 volts comes in here on the trigger side. So essentially, I'm using that same voltage to go to my constant power. But I also have this 9-volt battery that's connected in to it as well. And to prevent them from feeding back to each other, I have a couple of diodes in here. So I'm essentially just taking the output of the Liberty alarm, going through the diode into the constant power, taking the output of the 9-volt battery, going through a second diode, and going into the constant power. So when the power is applied, it's taking it's drawing current from the source with higher voltage, more potential. So that is the Liberty alarm system. And when that system goes away, then it starts drawing from the 9-volt battery. So just to repeat on that, I have about both on the 11-volt power supply and on the 9-volt battery, getting about 30 milliamps of draw when the relay is not energized. So the timer circuit is just sitting there running, 30 milliamps, and getting 90 milliamps when the relay is energized. Now the manual does say that after 5 minutes of the relay not being energized, that this display will turn off. I haven't seen that happen yet. It hasn't been that long. In that case, I should be drawing even less than 30 milliamps of power. And you may remember in my previous setup, the relay was always energized, so that display would never go off. The relay was only de-energized in an alarm condition. So, to recap, flip from the normally closed side to the normally open. We reversed the logic through the holding the down key. We've added a 9-volt battery power source in addition to the trigger source, feeding those both through a relay through diodes to the constant power source. I hope this is helpful. I think you'll see that there's a lot of ways you could configure this type of setup, and whatever way works best for you and what you're trying to achieve and what you have available should do it. Thank you. So here we are mounted back in the pump room with the modifications made. You see the 9-volt battery attached, the absence of a constant power source, And now we just have exactly hooked up the same way we were before to the pump alarm. The relay contacts go to the alarm contacts. The power output here feeds both the trigger and constant power source here now, and the 9-volt battery feeds the constant power source as well, going through those diodes, each power source going through the diodes, so as to not feed back to each other on the positive side. And everything seems to work well. So cleaned up the installation a little bit. The display, I don't think is going to go off after 5 minutes like the manual says. Supposedly 5 minutes of the relay being inactive, the display will go off. I haven't seen it happen yet. It could have something to do with the fact that we reversed the logic using the F2 function by holding the down key. That allows us to keep the same program that we had before, P4, but now use the normally open contacts instead of the normally closed contacts. So now our normal mode is that the relay is de-energized, and in an alarm condition we energize the relay to close the normally open contacts. Maybe a couple other modifications that could be made. I don't know that I'm going to do them. What happens now is when you first power this thing up, the first time it receives power, it goes into an alarm condition temporarily until it kind of awakes and senses the trigger. And so I think that you could possibly put a switch in here, essentially a disarm switch on one side of the relay, so that you could flip that switch once the thing was up and running, and you wouldn't trigger the false alarm. It's not a huge deal for me. I can take the false alarm for a second, and then it clears itself when I plug it in. And then you could possibly even set up a test button of sorts. You could put a button in line with the trigger power, so that kind of a momentary button, probably a normally closed button, that when you push it, it opens briefly, disconnects the trigger power, so that you could essentially test the countdown with unplugging the source. Again, neither one of those are really needed in my use case, but just some other things I had in mind. And just remember, this is all my information to you, no guarantees. These were some diodes that I had hanging around. Actually, I tried looking them up. I couldn't find any specs on them. They seem to work fine in this model. As with anything, you'll need to make sure that those diodes tolerate the 2 voltages that are going through them. And I haven't had any issue, but if you can, look up the spec sheets based on the power source you're going to be using. Make sure that you're okay there. Remember that the controller itself can take anywhere from 6 to 30 volts. And I think most diodes are probably okay at that range as well, but consult the product specs for whatever you decide to use. And finally, on this wire, 2 other things. One, this pump alarm says that it supports 100 milliamps of output on its auxiliary power. You remember this draws 96 with the relay closed, and 30 with the relay not relay activated, 30 with the relay inactivated. Now, because this unit will be unplugged in a power failure situation, and the relay will only be active in a power failure situation, we actually will never exceed 30 milliamps to this guy, because if they were in an alarm condition, it means that we're getting fed off of the battery during that time. So the wire here as well, this is, I believe, 24 gauge telephone wire, and I looked that up online. That should be able to support, based on what I could tell, at least 350, 400 milliamps, no problem. And this is drawing 100 max, so we should be good there. Thank you very much.